Okay, so section 4.2 is all about the different types of chemical reactions, and the warm-up does a really good job of outlining them. So the first type of reaction is called a synthesis reaction. These are also known as combination reactions, and generally speaking, you are combining multiple things together to make one product. So that's why it typically looks like A combines with B to make product AB. Okay, decomposition reactions are the reverse of a synthesis reaction. So here you're going to have one reactant breaking down into two different ones. So that means I would have compound AB breaking down into elements A and B. Okay, single replacement reactions are where you have one element combining with the compound, and what happened is the element will either be a metal or a non-metal, and if it is a metal, it will replace the metal in the compound, and then you'll kick out a different element, and then you'll form another compound. I will go over this in more detail when we get to that section. Double replacement reactions are where you have two compounds. So if I've got compound AB combining with compound CD, what happens is the cations, which would be the first substance in each compound, each cation will switch. If you don't write this stuff down, I don't know how in the world you're going to remember it. You're not. Okay, so what will happen is A and C switch, and you're going to form product CB and AD. So you form two new compounds. Then for neutralization reactions, you've got an acid combining with a base, and you're going to form a salt and water. Remember, acids begin with hydrogen. So generically speaking, you will see HA representing the acid because it's starting with hydrogen. The base will contain hydroxide. So you'll generally see the base written as BOH. The OH is the hydroxide. That indicates that it's a base. And then you'll form a salt and water. The salt in this case, using these symbols, would be salt BA, and then water would be HOH or H2O, okay? Lastly, you have a combustion reaction. In a combustion reaction, you will have some sort of an organic compound. Generally speaking, the organic compound is a hydrocarbon. That means it's predominantly made of hydrogen and carbon. Methane would be a perfect example. It combines with oxygen in the air, which is O2, and then you will form carbon dioxide and water as your products every single time, okay? What we're going to do is we're not going to balance numbers 1 through 5. I want you to classify each type of reaction that we have, and then let's go over it, okay? So take a look at it with the person sitting next to you, and let's see what... For number 1, what did you say it was? Single replacement, yeah. And just so you know, single replacement is often abbreviated as SR. You'll sometimes see them refer to it as single displacement, and then they'll write SD. It's the same thing. Okay, for the second one. Synthesis, perfect. I'm going to put an S for synthesis. And then for number 3. Combustion, okay. And then number 4.
Neutralization.
Yep, neutralization. And then number 5, decomposition. Awesome. Easy-ish. Okay, let's go on. And we're going to go through each different type of chemical reaction. This is kind of a long section, hence the reason I kind of wanted to just do this today because it can kind of be overwhelming. Okay, so once we're done with each section, I need you to let me know if you feel like you need more practice because I have plenty of worksheets for each section. Okay, so let's come down here and let's talk about synthesis reactions. So synthesis reactions are when we bring together a couple of simple things and we make something that's more complicated. So generally speaking, synthesis reactions will release energy in the form of heat. So they will feel warmer once they happen. So it says here that they would be exothermic because they are releasing heat. Sometimes synthesis reactions need a little bit of energy to get them to go. This is known as the activation energy. I will talk about activation energy in the next section. Okay. What else? I think that's it for this page. Let's go to the next page. There are different types of synthesis reactions, but let me go over a couple of things. So here you will notice that they wrote plus energy on the product side of this synthesis reaction. Anytime you see energy written, or you will see a number, like, let me give you an example, 15 kilojoules per mole. If that number was in place of the word energy, that is implying that energy is being released and that it is exothermic. Okay, so as long as it's on the product side, it's exothermic. Okay, now when you bring together two elements to form a compound in a synthesis reaction, here, for example, we've got barium combining with chlorine. You know that barium is Ba. Chlorine is diatomic. That's why it's Cl2. If you are writing something out like this and asked to predict the product of a synthesis reaction, I strongly recommend write it out in words first, convert the words to the chemical formulas, because that's the easiest way for you to get the correct answer. If you don't do it that way, you run the risk of mistakenly copying subscripts on the reactant side over to the product side, and you will think that it works every time, and it doesn't. So the way that they got this chemical formula is barium is +2, chlorine is -1. So that means I would need 2 chlorines to make the charges add up to 0. So that's how they got this BaCl2. You cannot look back here at the subscripts and assume that it's a 1 and a 2. Does that make sense? Okay, another example would be, here we have tin combining with oxygen. So as I said earlier, Vincent, I think you asked me, well, how do I know what the charge is of a transition metal when it goes into a compound, right? And so here in this example, since this is a transition metal, you assume that when you go to add it into a compound, assume that it's a 2. Okay, so this is what you assumed. Okay, so the way that we get the chemical formula is we have tin 2, and then oxygen is O-2. I would need 1 of each to make a neutral compound. That's how I get SNO. Okay, you do not get SNO by looking here at the subscripts on the reactants. If you had done that, you would have written SNO2 and it would have been wrong. Does that make sense? Okay, I think that's it. For advanced students, you will sometimes see a non-metal oxide combining with water to make an acid. Okay, so here they tell you when a non-metal oxide combines with water, the product is always an acid. You may not necessarily know what chemical formula will form for the acid. I would just know this generic sort of like sentence, and you obviously know how to recognize an acid. Okay, that's sulfuric acid. And I believe that's it for, oh, there's one more. Can I move this down? Okay, the other one is right down here. Metal oxides will react with water to form a base. Here is a metal oxide. Here's my water. Here's my base, because bases contain hydroxides, okay? So I would know that general sentence as well. And then the last one would be this one here. If a metal oxide reacts with a non-metal oxide, the product is a ternary salt, meaning 3 different elements would be in the salt. So here is my metal oxide combining with a non-metal oxide. Here is my ternary salt. Okay. Okay. That's it for synthesis reactions. Are we cool? Okay. Decomposition is just the reverse of that. Okay. So everything that I just said, I'm going to go in the opposite direction. So this should be pretty straightforward. So let's come down here. And since synthesis reactions release heat, decomposition reactions will absorb heat. Okay, so here it says decomposition involves taking some complicated compound and breaking it down into simpler pieces. So maybe it breaks apart into its elements. And since here we are releasing energy, which typically happens, I'm sorry, I didn't finish that. Reactions that absorb more energy to break bonds than they release when they form them are endothermic. So endothermic means we are going to absorb heat here, and you need this to break the bonds in the reactants. Common example here is aluminum oxide, decomposing into its elements, aluminum and oxygen. I think that's all we need for that page. Let's turn the page. The reverse of the reactions that we spoke of on the previous page for synthesis reactions. Here we have an acid decomposing, we have a base decomposing, and then we have that ternary salt decomposing. So the acid forms water and a nonmetal oxide. The base forms a metal oxide and water. The salt forms a metal oxide and a nonmetal oxide. They gave you examples right here. You wouldn't necessarily know how to predict these products, but you could recognize that they were a specific type of decomposition reaction, okay? Okay, now, everything that I just discussed is already organized for you in a table. So when we come down here to this table, you'll notice that synthesis is going to the right, decomposition is going to the left. Okay, so we've already covered all of this. This last row is just when we have something really simple. Okay, so for instance, here, if I've got something like MgO is my simple binary salt, binary meaning two things. If that decomposes, it will decompose into magnesium and oxygen gas. If I combine magnesium and oxygen, I will get the binary salt magnesium oxide. Okay? Okay. That's it for synthesis and decomposition. Okay? Let's go on to combustion reactions. I'm going to stop this video here.